At the dawn of the 20th century, physics seemed almost complete. Lord Kelvin, one of the most respected scientists of his age, declared that there is nothing new to be discovered in physics now. All that remains is more and more precise measurement. The great cathedral of Newtonian mechanics, refined by Maxwell's elegant equations of electromagnetism, appeared solid and unshakable. Space was the immutable stage, time the universal clock, and all phenomena, from falling apples to the movement of planets, could be described within this secure framework. Yet in 1905, a young man working as a technical expert in the Swiss Patent Office shattered this illusion of completeness. His name was Albert Einstein. He had not yet secured an academic post, nor did he have a laboratory at his disposal. Surrounded by stacks of patent applications on electrical devices, telegraphs, and synchronized clocks, he spent his days reviewing inventions, and his nights immersed in thought experiments. From this modest setting emerged one of the greatest revolutions in the history of science. In just 7 months, Einstein published 4 papers in the Annalen der Physik that would change physics forever. The first explained the photoelectric effect, showing that light behaves as if it is made of discrete packets, later called photons, laying the foundation for quantum theory. The second described Brownian motion, proving the existence of atoms beyond any doubt. The third, and most famous, introduced the special theory of relativity, overturning Newton's vision of absolute space and time. The fourth, a brief note, revealed the most iconic equation in science, E equals mc squared, establishing the equivalence of mass and energy. Historians would later call this period Einstein's annus mirabilis, his miracle year. But at the time, these papers were the work of a virtually unknown clerk, sent from the periphery of the scientific establishment. There was something almost paradoxical about it. The edifice of classical physics, built over centuries, was shaken not by a celebrated professor, but by an outsider with no official title, who dared to ask naive yet radical questions. What gave Einstein this unique vantage point? Perhaps it was precisely his distance from academia. In the Patent Office, questions about communication and synchronization were not abstract puzzles, they were practical concerns. How could 2 clocks in different cities strike noon at the same moment? How could signals sent by telegraph or railway ensure safe coordination? These seemingly mundane issues led Einstein to confront the very heart of physics. What does it mean for 2 events to happen at the same time? This was the seed of revolution. By taking seriously the finite speed of light, Einstein realized that simultaneity is not absolute, but depends on the observer's state of motion. The absolute stage of Newton crumbled, replaced by a universe where time and space are woven together, elastic and relative. The unexpected promotion was given to light itself. From a mere phenomenon among others, it became the ultimate arbiter of reality, the one quantity that remained unchanged for all observers. Thus began the second great revolution of astrophysics, the dethronement of absolute time and space, and the coronation of light as the measure of all things.